Often math students think of mathematics as having a whole bunch of rules, right? So math is just like dozens and dozens, even hundreds of rules. And you just have to memorize your rules, and they're all different. No matter what you're doing, there's a different rule for every different situation. And this document is my attempt to show you that there's not hundreds or dozens of rules. There's a couple rules that you have to keep straight, but the same rule is a common thread that goes through multiple different topics. And that is true when it comes to multiplication and addition. So we're going to look at the fundamental difference between how we multiply and how we add. And that's going to help you as we review fractions, as we review things like radicals and exponents, and as we work in algebra. But I'm going to go all the way back to whole numbers and show you that the rules that you've learned for addition and multiplication are the same, have the same basis as the rules that you learned way back in elementary with adding and multiplying whole numbers. So here is the fundamental rule. When you multiply, you must have like units. I'm sure you've all heard of the word like terms, right? In algebra, okay, we can only add if we have like terms. But I'm going to use the phrase like terms and like units somewhat interchangeably. Okay, so we have to have the same unit to add, and you keep those units. So think way back to whole numbers, right? When you were adding, right, you might have gone like this, and you only add the ones and the ones, and you get ones. Then you add your tens and your tens, because really this is 20 plus 40, or 2 tens plus 4 tens, which gives you 6 tens. And then if you get more than 10, then you have to regroup. But you are only adding like units. Now over here, I might be showing this product a little bit and in a different way than you might be used to. I'm showing the product 23 times 45, okay? But I wrote 23 as 20 plus 3 and 45 as 40 plus 5. Some of you might have been taught to multiply that way. But anyway, in multiplication, it's not like I just multiply 3 and 5 and multiply 2 and 4, right? I have to multiply every place by every place. So the tens place gets multiplied by the ones place. And also our units change. So when I multiply tens by tens, I don't get tens, I get hundreds, right? So 2 tens and 4 tens are multiplied to get 8 hundreds. All right, so when we move on to fractions, which we're going to be reviewing here, our like unit or our like terms are like denominators, right? So when it comes to adding fractions, I can only add them if I have the same denominator. Fifths and fifths get added, and the answer is fifths, right? Whereas in multiplication, I don't need the same unit, right? So I can multiply fifths by thirds. Or if I do multiply fifths by fifths, I don't get fifths, I get 25ths, right? The unit has changed. Something else that students will often mix up, and again, you've probably been overusing your calculators all these years and probably have not been asked to do things like this in many years, but even adding mixed numbers, right? It's very, very common for me to see students say, oh, that's 6 and 3/8, right? Because they just multiply the whole numbers and then just multiply the fractions. Mixed numbers don't work that way, multiplying mixed numbers without a calculator. I can't do that. That works in addition, right? Because in addition, I add the whole numbers, I add the fractions, like things get added to like things. Remember that 2 1/2 is really 2 plus a half, right? And then this 3 3¾ is 3 plus 3/4. Therefore, if I wrote it like this and I went to multiply, this ends up being our friend FOIL from high school. So remember in FOIL, if I was doing stuff like, you know, x plus 2 times x plus 3, right? And we had to multiply first, outside, inside, last. I don't know. Some teachers nowadays are saying They don't like FOIL, right? They call it double distributive property. I don't know. I don't see anything wrong with saying FOIL, right? So first, outside, inside, last, right? I know more teachers are starting to do some stuff like this, right? Where they write x plus 2. I like this visual. For those of you that are a little more visual, you like this better, right? And then you multiply here, 2x, x squared, 3x, 6, and add them together. But anyway, the point that I'm making over here is that if I were to write these fractions out as 2 plus a half, 3 plus 3/4, I would have to FOIL. Now, that's not how we multiply mixed numbers. The rule for mixed numbers is, let's see, 4, make them improper, so this would be 5 halves, right? In order to multiply the entire quantity by the entire quantity, we make them into improper. So 3 times 4 is 12, plus 3 is 15, 15/4, right? So when we go to multiply mixed numbers, we change them into improper fractions so that we don't have to do this FOIL business, right? This, just multiplying across the top, across the bottom after we've made them improper, is easier than FOILing. But again, same rule with decimals. I'm almost starting to feel like nowadays, I'm not even sure how much decimal arithmetic is it's still being taught, I know that, but really being emphasized. I think you probably have picked up a calculator and done all your work with decimals long before you ever learned the rules for doing decimals by hand. But again, multiplying and adding have the same rules, right? To add decimals, you line up the decimal point. To multiply, you multiply every place by every place, and then you adjust for the decimal point at the end. You count the places to the right of the decimal point, and then you move your answer. After you multiply, you would move the decimal point 3 places to account for the 3 places behind the decimal point. So in our class, I'm not going to make you do stuff with decimals by hand. But coming down here to some of the stuff we'll use more in our class, in algebra, right? If I am in algebra, I must have like terms, right? So 2x cubed plus x cubed is 3x cubed, right? The unit, my unit is x cubed, the unit stays the same at the end, right? Same thing with radicals. These could be considered like terms. I'm adding 1 radical 2 plus another 1 radical 2. In the end, I have 2 radical 2. Okay, so many students try to call this radical 4, and they do that because over here in multiplication, I just multiply what's under the radical, right? And then students are left saying, well, why can't I just add what's under the radical, right? But that's because adding, we must have like units. Multiplying, we never need like units, and the units change. So in addition, right, this can't be multiplied. Or I'm sorry, this can't be added. I misspoke. This can't be added because they're not like units, but over here I can multiply them. And again, if I do multiply when I have the same unit, notice the units change. If I multiply x cubed times x cubed, I get x to the 6th, right? Because I have to add the exponents, okay? But over here in adding, the unit stays the same. So again, anytime you find yourself working in fractions, working in algebra, right? If you can always remember, like units to add, keep the units, never need like units to multiply, units get multiplied. That will go a long way in helping you be successful in math in general.